Welcome, everyone. Welcome to today's Tech Talk. We're very pleased to have Deborah Estrin and her colleagues, Jeff Burke, Dana Cuff, Mark Hansen, Jerry Kang, William Kaiser, Michael Hamilton, Fabian Wagmister, all from UCLA. These faculty are members of UCLA's NF Center for Embedded Network Sensing, which Deborah is founding director of, and the Center for Research on Media and Performance. Their presentation today is on urban sensing, social networking, and the third thing, how sensors and data will dominate tomorrow's global network. Please join me in welcoming Deborah Estrin and colleagues from UCLA.
Thank you. It's a pleasure to be here. So, as we've been finding over the last several years, embedded network sensing is revealing the previously unobservable in many science applications. If you look at the top left to lower left, you'll see a figure of each of the 4 science applications that dominate most of our work to date: seismology, terrestrial ecology, environmental sciences, and marine biology. And when we look back over these past several years, we've really made our greatest strides by using multi-scale data and models as a context for our in situ observations, and in-network processing and mobility to achieve scalability from a perspective of communications, energy, latency, coverage. Mobility is really, as we've discovered, the only way that we achieve dense sensing, by moving sensors through an environment as opposed to just placing them statically. And in-network processing is essential because by processing data near the source, we not only make the system last a lot longer instead of wasting energy on unnecessary communications, but we make the system far more reactive and interactive, so that elements of the system, human and automated and electronic, can actually adapt to the varying physical inputs that the system is experiencing. So this brings us to today's topic of personal, social, and urban sensing applications that we anticipate will exploit the installed base of image and acoustic sensors that we all carry around in our pockets or on our belts. In other words, the cell phone handset. But we see it going well beyond today's largely intentional conversations and postings that are enabled by sites like Flickr and Lifeblog, etc., to a growth of automated, programmable, and adaptive collection of acoustic and image profiles of our personal, social, and urban spaces. And we believe that this will unleash the power of what is really a very widely deployed, but we believe underutilized embedded network sensing capacity. So as a sensor network person, when I see a cell phone, what I see is a wireless sensor. And I was told not to use a certain pun, yes, but in Vince's honor, even though he's not here, I mean, if you will, this sort of underutilized capacity you could think of as being sensey at phone. Now somebody laughed because I was told that nobody would get the pun if they didn't see it in writing. See, he's laughing. SETI at home, sensey at phone. Anyway, what's interesting is that we really see a lot of overlapping themes between the science applications that we have been addressing over the last several years and this new space of personal, urban, and social applications. And one of the most important ones of those overlapping themes is the crucial importance of processing the data close to the sensor source. And in this case, in the case of personal, urban, and social sensing applications, it's critical to do this sensing and processing, the processing close to the sensor source, in order to address the varied but persistent needs of individuals to selectively share these direct observations of their lives and their spaces. So whereas in embedded network sensing for science applications, we did in-network processing for scalability, longevity, and latency, in these applications, we need in-network processing, on-node processing, and programmable and adaptive processing to address those needs for selective sharing. We also see the persistence of our other themes, mobility in order to achieve coverage of the city, and the challenge of mobility that it represents for verifiable location tagging. And we continue to see the absolute importance of viewing and analyzing these in situ measurements and observations in the context of multi-scale data. So as we found in embedded network sensing for the sciences, there are many interesting technical themes, and there's a strong need for designing the software that runs in these systems really across the platforms, across the embedded platform that you carry around with you, as well as in the back-end servers that support them. So it appears that from the existing embedded network sensing approaches, that much of our work that has been done in the context of the sciences really applies in the context of these applications as well. We see the need for multi-scale sensing and actuation to support ubiquity, in-network processing for privacy, analysis and visualization to enable discovery, and that we see emerging a data-centric architecture that has some strong analogies to that has emerged in the sensor network space. So what we'd like to do through this talk is largely focus on these personal, urban, and social applications. But before we do that, we want to take a few minutes before we launch into the urban space, to look at how science applications have really been transformed by this combination of embedded sensing and GIS integration and mapping tools. I don't know how, probably all of you saw the issue of Nature magazine that came out a few weeks ago, in which Declan Butler did this whole series on how Google Earth has started to transform scientific investigation. And so we'll start with Sean launching into that, the power of that integration that we hope to carry over into this urban space. And then Jeff Burke will take over and escort us into the city.
Hi, my name is Sean Askey. I'm a graduate student at UC Riverside, and I'm going to switch over to this laptop, so give me one sec. So I'm hoping that most of you guys aren't sick of flying around the world yet, because we got a little more to do with that today. I work at the James Reserve, which is a part of the University of California Natural Reserve System. It's near Idlewild in the San Jacinto Mountains near Palm Springs. And at the James Reserve, we have a number of sensor platforms, everything from microclimate weather stations, webcams. We have robots running on high-tension cables taking transect measurements. And I'll try and show you a few of those systems today, and maybe some basic scientific questions we can answer with these systems. One of the main advantages of Google Earth for us is that we can really customize a lot of our data visualization to certain audiences. We have K through 12 education. We have birders who enjoy looking at nest boxes and roosting birds, bird feeders, and of course the biologists who are using most of the sensors at the reserve. So fly around a little bit before I start showing you about the nest box system. So we have a system of nest box bird boxes at the reserve, which feature webcams and sensor measurements. One of the basic questions we're looking at the James Reserve is why do certain birds pick certain nest boxes to roost in, to lay eggs in, and rear their young? And we're interested in looking across the board at a lot of different locations to kind of figure out what's going on, what type of microclimate variations are leading birds to choose one place over another. So here you can see it's snowing like crazy down there right now, so unfortunately most of our stuff is white, blanketed in snow. But this bird box, I believe, last night had a bird roosting in it. You can see there. We can use Google Earth to interface more information about these webcams and also looking at the sensor measurements. You can see here's a trend line for temperature over the last 24 hours, and we've been below zero. Let's take a look at that. This is a Java applet that we use to visualize data streams. Some of the other interfaces that are connected to Google Earth include the ability to look at measurements side by side with a time sequence of images. For example, here are two nest boxes over the period of about a month, and you can see the temperature and humidity measurements progressing. And I think there's some interesting bird pictures here. That's encouraging. Or maybe not. Well, we'll come back to that later. This is a violet green swallow here at the bottom. And nope, no luck today. Sorry about that. So anyway, so we're hoping to look at kind of the whole picture here and see a lot of different nest boxes at the same time to start answering scientific questions. Another question we're looking at is dealing with water quality and algal and bacteria blooms in bodies of water. This is the NAMOS and Roboduct system, which is monitoring the lake that we have at the reserve. These are buoys that take measurement values on fluorometry, which is a measure of chlorophyll in the water. We also have a number of overlays that are, some of which are generated dynamically. Here's like a model of water temperature at the lake. Here's a fluorometry measurement. We also have this autonomous robot that skates around on the lake and takes measurements along a transect. One last system to show you really quick before I pass it off is the cold air drainage transect. Characteristic of a lot of mountain valleys, kind of late at night, you'll have a big dumping of cold air in the middle of the night. This is interesting and important to look at because a lot of the plants and animals that live in the valley are really sensitive to minor variations in climate change and will choose where they live depending on some of these conditions. So here we have a couple of our transects. We've integrated some GIS information into this. Give you some contour lines. Let that load up for a sec. This is a measure of slope aspect, which is the direction a particular face of a hill is pointing, red being north, and moss grows on the north side of trees, in part because there's less sunshine, which kind of influences a lot of these climate conditions. One of the things that we're doing is taking all of these point data from these transects and doing kind of a spatial interpolation called a Krieging model. And what that allows us to do is kind of generate, let's go here, kind of like a pseudo animation of how temperature is changing through time. And as Google Earth improves and maybe has some more native support for animations, you would be able to look at this cold air drainage and the temperature flowing through the valley sort of in animated real time. And one last thing to show you, kind of leading into our urban sensing applications. Would be the system of webcams that we have at the reserve. We have a number of webcams you can view right in the Google interface and take a look at what's going on. And we also have an audio feed. That I'll see if I can play in the background. And with this, users can have a quick snapshot of all the webcams that are on site and quickly take a look at what's going on. And unfortunately, like I said, for the most part, we've been covered in snow. But you can hear some birds in the background, hopefully. So anyway, I'm way over time, so I'm going to pass it back to Deborah. A variety of different ways. We have solar panels. We have a diesel generator. We're off the power grid, so whatever we don't generate from the sun, we have to burn in diesel. Yeah.
So if we had the transition worked out, this at the end, I think Sean would probably zoom back into a city after looking at those webcams. My name is Jeff Burke. I'm from the Center for Research in Engineering, Media, and Performance which is in the School of Engineering and the School of Theater, Film, and TV at UCLA. And we've been involved in this sort of intersection between art and technology, and now I think at the end, Fabian will talk a little bit about our engagement with communities, but for about the last 7 or 8 years. And we've always been interested in sensing because it implicates people's bodies and positions and movements in space with control over media and gets us away from the keyboard and the mouse as an interface to media and an interface to information. And so as SENS has made this interesting transition from sensing in natural environments for scientific purposes to looking at urban environments for the purposes of facilitating the communities that are already there, for enabling social science study and urban planning. And we've been making a sort of similar transition ourselves that is from looking at individual artworks and particular artworks to looking at platforms that serve groups of people interested in either expressing something, sharing information, or sharing data, basically participating in using sensing to express or show information about their environments. And so what I'd like to do is just provide a really brief transition from what you've seen about SENS and sensing in the scientific domain to the next 4 speakers who are going to talk about sensing in the urban domain, in the domain of communities, in the public sphere. And really that there's a transition that's going to happen and is happening from people capturing moments on their cell phones and storing moments and uploading moments to really creating ways of capturing the rhythms of their lives, of sampling their lives, whether it's photographic or acoustic or these other types of sensors that SENS is already using, either from mobile handsets or from devices placed in environments that we're already moving through. And so in a sense, we're returning back to the physical world a little bit, and the domain experts are the people who are going to be using these sensors to sense things about their lives, about their cities, about their communities. And Jerry and Mark and Dana will mention epiphanal data flows, the idea of encountering something for the first time, understanding something for the first time out of the data that are coming from these sensing systems. And then I think you'll see a little bit of a different presentation from Fabian and also what I'm talking about, is a sort of articulated data flow, picking a way of sensing a city or a way of looking at a particular community to expose something that we already know a little bit about, to say this is a rhythm that I recognize in my life or in my community, and I'm going to actually construct a way of sensing, of learning more about that, and then presenting it. And so I wanted to give just 3 spheres of data sharing and 3 simple sort of mundane examples that hopefully you'll get the more fun examples in the next couple of talks. But so when we say personal, social, and urban sensing, we're really talking about different types of data flow. For example, in the personal, a data stream or data that I have a lot of stake in, and I'm not necessarily going to share except with people that I trust a lot. So for example, personal health monitoring. This idea that I may have sensors as an outpatient on my body, sharing things with my healthcare provider, enabling them to provide better service to me. This is a choice that I make privacy-wise about something that I want to enable for my healthcare provider. This is an example of sort of personal data sharing, where the data-centric architecture that Deborah mentioned at the beginning would be enabling still resolution control over how much and when I share that data, but it's something that's negotiated between me and somebody that I trust. The second is this social scale of data sharing, typically built around this idea that I already have an existing social contract with a group of people, maybe just based on where I live. So one example of that kind of application is rather than sharing images or tagging images and posting them to the web and sharing them based on either a group of people we already know or some shared set of keywords, this idea that a network that would have intrinsic ability to verify location and time of when this data is collected would enable us actually to share data based on how much time we spend in particular locations, for example. So if you think about Eric Paulos at Intel Research uses this example of familiar strangers in urban environments where there are people that I run into in the city when I go on public transportation day after day that are comfortable, that comfort me knowing that they're there. They're people that I have a connection with but don't enter my social sphere because of this continual rhythm of presence where they're in the same place. This idea of a network that can verify location and time of when this data is collected enables this kind of new type of anonymity, but verified anonymity that says this is somebody that spends a lot of time in this place. Therefore, maybe they have some stake in providing information about it. The third is an example of a much more anonymous and maybe familiar and actually a lot closer to the scientific application of this data sharing on an urban or city scale. So for example, Los Angeles is about to do a giant renovation of a downtown area, the Grand Avenue project. And one thing that USC did was a center at USC decided we want to involve the community in planning for this project or a certain portion of this project. And so they created tools to allow people to submit their ideas about this architecture, right? But one of the things that community of people didn't have was design expertise or data. They didn't really have access to information about data about the city that would enable them to participate in that design exercise in sort of an interesting and engaged way. So you could imagine that, for example, noise level mapping, which sounds very mundane, but actually is very connected to quality of life and people's perception of quality of life, this kind of enabling those type of systems offers this idea of a participatory urban planning tool. I think we'll come into what the next talk is about, where I have anonymous data, or I enable the capture of anonymous data and then use that to understand the city that I live in and use that data to participate in the urban planning process. So these are very quick examples just to explain what we mean by personal, social, and urban sensing. And so then the question is the third thing. And I've let the Macintosh muck with my fonts, so I'm sorry for the underscores and things a little bit. Just giving you a hard time. So one of the things that you'll notice about the next series of talks is they aren't work applications and they aren't leisure applications. So the typical application of, say, designing for efficiency. What's the fastest way? What's the best way for us to deliver entertainment per unit time? How do we enable people to do tasks quickly? May not fit in these type of applications. They're closer to social networking. They're closer to discovery-based applications that have less to do with the tasks that I want to complete than my identity, than the place that I am, than what I value and what I feel responsible for. And so I hope that as you go through and listen to these next set of talks, you keep in mind that what we're trying to figure out are what are the design frameworks for these applications. If it's not efficiency, and if it's not how many tasks can I do, what will it be? And so I hope that's something that contextualizes the next set of presentations for you.
So there will be three of us who are talking, which will make it a little unusual, but we'll move in and out. I'm Jerry Kang. I'm at the law school. Mark Hansen from Statistics and Dana Cuff from Architecture and Urban Planning. And our talk is about common sense. Let's start. Where's the... I'll do it for you. Excellent. Three big points that we want to try to convey. The first is participatory sensing, second is data commons, and third, building places. The first point is to just show you in which ways people will use sensors and actually collect new kinds of data in unexpected ways. The second point is to suggest that these data can be put into a common pool. And there are important both design and legal incentive questions that have to be answered to make sure that the data commons flourishes. And third is what we do with an actual data commons. What do we build on top of it?
So if the experiments that we've been doing with bottom-up or participatory sensing has primarily been about lifestyle, individuals, the kind of connections between individuals for atmospheric effect, the next generation of that peer-to-peer sensing is going to be about the public sphere, about groups of people, about the urban condition, and potentially engage more responsive sets of sensors and processors and actuators.
Building on some of the science work that you saw previously,
Can you hear?
One question that we get, oh, for the love of, all right. Nice. One of the questions we get a fair bit is, yeah, the extent to which, to kind of maybe ground this conversation a little bit, part of what we're talking about here is people getting involved in that sensing or that data collection process, so not have it sort of orchestrated necessarily by a James Reserve or by a science organization, but people getting involved in their own sort of data collection. And you can kind of see the will of the people, if you will, to participate in these kinds of things in the sense that current participatory science applications have a lot of uptake. So things like the Cornell's Backyard Bird Count project, where people are encouraged to report on the number of different kinds of birds they see in their backyard, or the USGS's Did You Feel It site. So every time you see, or every time there's an earthquake, you type in or give them your zip code, and as well as a sense of how strong the earthquake was. So people are, and these sort of things get lots and lots of uptake. People are very willing to share and very willing to participate. The interesting thing for us, I suppose, is that people are now, I mean, these data are connected to places. So it's data connected to a place. It's a rallying point, if you will. It's a community building up around data. The participation, though, like the science applications you saw earlier, the participation is somewhat limited in the sense that you're only allowed to upload certain kinds of data. The kinds of visualizations and the computations that you can do very much frame the kinds of conclusions you can make about the data. So organization and access, in a way, frames the question, or the questions that you can ask about it are determined for you. And finally, in the case of either the Cornell University or the USGS, there's a central authority that's saying that these data are trustworthy, or they're doing a little bit of filtering to make sure that data aren't sort of bad quality, and there are privacy guarantees so that you're uploading information and they're not going to broadcast information about you.
I would just add to that that it's fundamentally changing this notion of distributed information, that we now can locate that, and in fact inherently have that located spatially. That for the longest time we've talked about the internet removing space from something like community, that we have community without propinquity. Whereas now, though we might not be next to that community, we know where it is. So not only is the environment rich with information, but we both gather information and send it from specific places and document it from those places.
So we go from those sort of top-down science applications that have a lot of uptake, that people are very willing to participate in, to perhaps something that's a little more bottom-up. And we can take inspiration for that kind of thing from blogs or video logs that are having people sort of contribute data and affect a kind of localized reporting, if you will, but it's done in a very ad hoc kind of emergent way. There's not, I mean, there's a channel that's formed, but besides that, there's not a central organization saying, give me this kind of data in this kind of form. And so what you're starting to see, so then one effect that you're probably all familiar, well, you have to all be familiar with it, are these kind of blogs and video logs, and that sort of webby kind of data that are getting shared and uploaded and linked. But we're also seeing actual sensor type data of the sort that maybe is a little closer to what the science applications we're talking about, sort of finding its way into expressive works. The webcam up in the upper right corner is from a piece by Natalie Jeremijenko called Fade to Black, which is basically a set of webcams that are installed on the top of buildings in various cities. They're facing up, and the idea is that over time, the junk in the air for each of the cities will settle on these webcams, and eventually they will fade to black. But that you could have a look at this network and get a sense of what air quality might be like in the city at that time. Now it's not calibrated, it's not anything like, you know, it's not science per se, but you're sharing data in a way and giving a view of your community. This is another project that has that same feel. It was from a design class that I taught last spring, in which a couple of architects went around in a series of places in Los Angeles and pointed a camera at the sky and took 6 compass points pictures. Those are the pictures on the bottom, just at the night sky, and then created an intensity map, if you will, of the light coming off of Los Angeles at various parts of the city. And what you get is almost a skyline where the heights of the yellow blob mass represents the intensity of light in that particular neighborhood. So you see the port glowing brightly, but downtown, because we have a somewhat anemic downtown, isn't very bright at night at all.
So since I don't think it takes a lot of work for us to persuade to you that participatory sensing with new sensors in a distributed way will actually happen. Now we have to turn to the question of how it is that we start to collect and join all these data together, and raises both user interface and later on more legal liability questions. So let's first talk about user interface and how we design that infrastructure.
Right, so when you think about people sharing data now, and not necessarily just sort of web pages or images or what have you, but data, you're sort of moving from, well, we're thinking, where do we look to get inspiration to help people share that data or make use of it? And so one source of inspiration from us would be to think that adding sensor data to kind of a reporting of your life, well, that takes you from a blog or a video log to maybe a sensor log, which we just call a slog, where people would be contributing data and having a more rich, perhaps, view of their lives. And then the question is, because these sort of urban applications necessarily involve sense making in a city or in a place, that sensing in the city is giving you, well, you're learning something about the inhabitants, right? People are caught in pictures, people are caught in cameras, and what does, in some cases, you want to think about the confidentiality or questions of confidentiality come up when people start sharing data like that. So we've been thinking a little bit about what the network can do to help aid anonymous or pseudonymous sharing of information. And then we have to think about what the interfaces might look like. Should an interface to data look a bit like a video log or a souped-up newsreader where you have subscribed to people's data feeds? And now you want to see what that sort of main window looks like if it's not video. Or is it mapping? So here is our sort of version of the Google Earth application where we did a little bit of walking with a just scanning for wireless networks and plotted out the names of the various networks that we found on a bit of, well, my neighborhood. So it's Fountain, our suites are between Fountain and Santa Monica. And you can see lots of things like, F you, get your own network, and get away, and you stealing my shit, sort of as labels of these. So there's an awareness of our personal space and our,
You have to guess which one's Mark's airport.
Yeah. Okay. Anyway.
Where are we?
So, I think Google celebrates it being a company in which engineering and good engineering actually drives things, but sooner or later the law gets involved, and we recognize that. There are important incentive questions on whether or not a data commons gets created. We're familiar with the Creative Commons conversation. Let me talk about at least 3 different things: privacy, property, and tort law, and maybe focus on unexpected connections between law and whether or not a data commons will be created. The privacy issues are at least abstractly well understood. And the general question that has to be asked is, will privacy fears prevent a data commons from being collected in the first place? I have the icon there is total information awareness. You might think, oh, that's a government project, a defunct government project. Why is that relevant to the kind of commercial marketplace context that we're talking about? The public-private distinction between government collection and processing of data and private has more or less collapsed. As you know, governments, when they need to, will either take it or subpoena it. And so the bright firewall that you might actually think exists between those lines don't exist in actuality. And so the question becomes whether in-network, at-the-node collection processing, ex-ante embedding of privacy imperatives are better and superior than ex-post litigation after the fact. Privacy is a well-understood space, and we could talk more about it in Q&A if people are interested. Let's think a little bit more about property, and this is always in the IP context. And one could ask, will lack of property rights prevent a data commons? That is certainly the story that is told with intellectual property in the form of copyright. But copyright laws don't apply to underlying facts. It's only to creative expressions that you could actually copyright. So the underlying data are not, in fact, protected. This is what's prompting a lot of people to call for what people say are sui generis database rights. Like if you actually collect a lot of data, it's not copyrightable, but because I did all this work, I should be protected, and you can't access it. So people have made the claim that you must create new property laws to protect data. You could make the argument just the opposite. Will the very existence of property rights destroy a data commons? This is consistent with the Creative Commons model of how we should actually share information. And although people are familiar with the idea of the tragedy of the commons, you should know that there's a lot of intellectual work about the tragedy of the anti-commons. The idea is that if you create too many property rights, then in order to actually get something done, create something, create a new invention and or creative work, you need to clear too many property licenses upstream that were necessary to produce your invention, and because the transaction costs are too high, you never actually end up creating anything. This is in the conversation, for example, patenting express sequence tags on DNA streams. So what we do about property and whether we require property rights or whether we fight against the concept of property rights will have a huge impact on whether a flourishing data commons is in fact created. The final thing, which I think is really probably the most interesting, at least from a legal perspective, are questions about liability and whether or not the possibility of liability could spoil a nascent or flourishing data commons. There's lots of ways where you could be held liable, arguably. Maybe it's defamation. It's a false statement of fact that undermines something about a person's reputation or a person's possessions. It could be negligent uploading of data. If you report something from your sensor that there's toxics here, and it turns out to be, in fact, inaccurate, and somebody's property values go down, they will want to sue you. What result? Now, most of the time, they won't be able to sue you because either they don't know who you are, and more important, you'll be judgment-proof. So who do you go after? You go after deep-pocket intermediaries, enter Google, or anyone else who might be providing the actual servers or infrastructure. This is where there are really interesting, unexpected legal reinforcements of the data commons that I want to just mention just briefly. There are two things, one arising from the porn wars, Section 230 immunity, and one arising from political speech wars that end up substantially immunizing firms like Google in actually producing and creating a data commons. So Section 230 immunity basically says the following. It was passed in the 96 Act. It was part of the Communications Decency Act, where people like Ashcroft and the people before him were really interested in shutting down pornography. It basically says this: no provider or user of an interactive computer service shall be considered the publisher or speaker of content provided by another information content provider. What does that mean? Long story short, if you're just providing the platform and somebody else uploads the data, even if you cut it and visualize it and show it in different ways, even annotate it, you will not be considered the author of that content. So even if it's defamatory, you as the intermediary, the person who supports the data commons, won't be held liable. This is not only for defamation, it's also been applied for things as disturbing as child pornography in terms of civil tort actions against firms like America Online or eBay and other kinds of things. So this immunity that was purchased in Section 230 back in the 1996 Act to deal with pornography has had these unexpected consequences for protecting firms like Google, America Online, and eBay, which we could leverage for the good. The other thing is, and the picture at the very bottom is an actual aerial shot of Barbra Streisand's house. The California Coastal Project was a nonprofit research project that flew across the coastline and took pictures to see what the state of the coastline looked like. Barbra Streisand was deeply offended, thought her privacy was invaded, and sued. California, like many states, had passed an anti-SLAPP statute. It was basically to help the little guys who are protesting big firms like McDonald's and saying that, look, if McDonald's sues you to shut you up and you're trying to engage in a public conversation, then we will quickly decide whether there's any merit, and if McDonald's loses, then they have to pay your attorney's fees, right? It's to protect public conversation and engagement from frivolous litigation that happens very early. They used this statute and Section 230 immunity to win the case against Barbra Streisand. There's no privacy interest here. Moreover, Streisand had to cut $177,000 in attorney's fees. That switches everything. Little things like whether or not you have to pay attorney's fees alters the relative power between big players and little players in the prospect of producing a data commons. So what I want to emphasize is unintended consequences. No one who passed this statute, Section 230, no one who passed anti-SLAPP statutes thought that in the end it might help promote what we're calling a data commons. But without question, there'll be incredibly, critically important elements in producing a data commons for firms like Google. So finally, we're at the third stage, and we're almost done. We want to try to figure out what goes from here. If people will collect the data, if because of the law and the underlying incentives, personal, political, and social, people will contribute to a commons that flourishes, what will be built on top of that commons? If it's foundation to a house, if it's architecture to a city, what will people build, and who will choose what will people build?
So if there's this sense of the conceptual level of the commons, that it's an ethereal construct of the multitude or the community, we also know that what actually gets shaped in that commons depends on what the platform or the infrastructure is that gets built underneath it. And that infrastructure is going to be policy-oriented, it'll be legal, and it will certainly be technological. The analogy to an urban infrastructure is apparent. I mean, if you look at, say, Paris in the 19th century, the effort that it took to rework Paris by Haussmann when they needed to open up the streets to prevent citizen revolution and to keep military connections alive was massive, and the destruction to the city was tremendous. The end result may be the spectacular diagonal swaths cut through the city, but certainly you'd want to start with a better idea of where you were going to end if you could. Similarly, the problems of setting up inadequate infrastructure was made most apparent to us in Katrina most recently, where tremendous kinds of devastation happened because of the inadequate levee system. That same kind of metaphor operates, if we think about it, on how we establish the groundwork for a data commons. And Mark's going to talk about that for a minute.
Well, this is again a crowd that knows this well, that if we take an example, for example, from healthcare, I've been teaching a grad seminar this year that looks at different organizations and how they make use of data and data processing. And within Los Angeles, we have a nice example of UCLA Medical Center, which is about half paperless, the Veterans Administration, which is 100% paperless, and then poor Cedars-Sinai, who tried to mount an electronic medical record, and the whole thing came crumbling down. And the architecture, or the comparison here with an architecture of the city is that, as you all know well, sort of organic database management systems that sort of, kind of come up in a sort of a random way need to be knitted together, and sometimes that communication or trying to bring the back end together can be very difficult, which will prevent you from being able to do the kinds of things in the context of healthcare, for example, that you assume could be done, like at a hospital be able to say, call up for me all the patients who have pneumonia and let's look at the kinds of treatments they received. Those sorts of operations are actually very difficult in, well, UCLA Medical Center, for example, because of the fragmented way in which the database systems have arisen.
Some of the kinds of infrastructure that could be established within the public sphere, and we would say all of this is public, even though some of it's consumer-driven and some of it's citizen-driven, some of that infrastructure is set up by the market. And in part, this is a way for us to think through, well, why not just let this stuff happen naturally? Why not just let it emerge from the 1,000 different bloggers, sloggers, and who's ever out there so that they figure out how to use Google Earth in a way that locates more information spatially, for example. And we see that happening in the market-driven attitudes about, say, shopping, where shopper profiling, more customized information, highly customized information, could be sent to particular kinds of shoppers with interests that would serve the people selling the products. Similarly, though, you could imagine something that's like political shopping that's more citizen-driven, where you went into a mall and you could actually find out if the clothing you were buying had used child labor, or if a store sold fur or was engaged in animal rights practices, or whether they use recycled products. So I think that it's only to say that there are ways in which a kind of citizen-driven system might also have filters within it that, am I shutting us off? Just about to. Might have some filters within it that would allow us to gather information collectively that might not have a market-driven interest. What if, for example, we wanted to know where the majority of accidents happened in a city? Could we have our cell phones programmed such that every time squealing brakes were heard or horns honked, that it would actually send a charge and blip into a larger data net so that we could aggregate that information and understand which were the dangerous intersections in a particular city? One of the reasons I think it's interesting for us to have this cross-disciplinary collaboration is because the ability to cross between, say, design and statistics and law and engineering has yielded some very provocative results. These are some that are primarily design-driven. Mei Jin-yoon, an architect out of Boston, set up this white noise, white light project at the Athens Olympics, where as you moved through a field of light sensors, they moved along with you on rods that were illuminated at the tip, so you could see traces of people moving through space. Though the application in this case is purely aesthetic, you could also imagine it having some kind of record or memory of activities in space that might be useful. The weirdest one here is that upside-down plastic bag thing, which is actually a giant sculpture in a town called Deutenham, Netherlands, which is a giant mood ring. And as people answer emotion questions on the internet, that sculpture records them so that when you drive into town at night, you know if people in that city are angry or loving or jealous or happy. I think one of the most beautiful ones is the Blur building at the Swiss Expo, in which an entire building was made of fog, and you were to get a raincoat that was actually called a brain coat, which would be coated with information from you that you wanted to share with others as you moved through the space. So I might say, professor, UCLA, interested in design, looking for friends with children under the age of 6. And my red light would light up as I passed someone else who had a similar answer on their brain coat. But clearly conceptual projects, on the other hand, allowing us to set new kinds of community.
So we wanted to end with, if we've sort of given you a sense that there is kind of a will on the part of the generals, that looks dangerous, to people to share data, that sensors are going to make that kind of will make that a richer kind of sharing. And then eventually what's going to happen if the data commons starts to exist is people will start to query that, will start to look for patterns, will start to search for things, if you will, and will start to sort of make up stories about their environments. We contrast this kind of, on the left we have 2 projects that I worked on that are sort of responding to what you might think of as collimated news sources. The one on the top is an installation that was designed for a news organization in Manhattan, and the one at the bottom actually uses a feed from Google News that, if Marissa may, she's not here, but that we set up so that this is a project on the outside of the new Moscone Center expansion, and we're getting a feed from Google News and reprocessing it and telling a story from official news sources. But what happens when people have the ability to kind of create or make sense of their own environments without having to depend on the news to tell them what's going on, or the EPA to tell them what's the condition of their backyard, but now you can put sensors out and make your own kind of view of it. So then the issue becomes, what is interesting in the data, who asked the questions, how are the results presented?
Yeah, we're basically done. If Google says do no evil, and if it's insipid but now true, Larry Lessig's statement that says code is law, and what you do is build code, then you have to make sure that you recognize that the data commons you helped create will have implications on what's going to be built on top. You have to think beforehand about how it is you're going to create a future that you want your children to live in.
Now some music should start up with that.
Hello, everyone. My name is Fabian Wagmister. I'm a professor in the School of Theater, Film, and TV. I actually come from a completely different part of the universe than most of my colleagues. In that, either in South Campus or in disciplines like architecture with a different set of parameters, standards, measurements of quality and success than where I come from, which is the world of the arts. And basically, I'm just an artist who has become very interesting with computers. Let's see if I can get this machine first. I think it went to sleep while we waited. No. That was a joke. Okay. And what I'm going to be talking to you about is a very exciting new project that we are getting involved with at UCLA and with the School of Engineering, in which we, together with a number of community organizations throughout Los Angeles, the California State Parks, and segments of the city of Los Angeles, are starting to think of what can a cultural civic computing system be like before and how it should be constructed. So that my topic has to do a lot with what are the possibilities for such a thing as civic computing systems. And I don't know if somebody's going to come up and help with the projector. Let's try a couple of things. Is that? Yeah, I see my screen, bro. Hold on a second. Wait. There we go. All right, not too bad. Okay, one of the principal concerns that philosophers of technology. Okay, that's me now. Is somebody switching? Are you switching the? No. Okay. I'll talk about me on the screen, talking to you on the screen, talking to me on the screen. If somebody can help me out get that my stuff back, that'd be great. No one. So one more time. I am from Argentina, and I've suffered oppression before. I know what's going on here. All right, let's try again now. That's right. Let's hope that. Sorry about that. If that doesn't work, we'll try something else. I just tested it a second ago. Let's try something else. Okay, we'll try this one then. Almost there. Okay. Okay, I was about to start when we went through all this stuff. Almost there. Again, this wasn't the presentation I was going to show you, but it'll do. All right. So as most of you know, one of the key concerns of philosophers of technology, sociologists of technology, thinkers in general, has to do with the issues of cultural specificity in relationship to technological development. Basically, how do specific cultures express themselves through technology, and how they maintain the capacity to develop culturally specific modes of identity in the context of sophisticated technologies that they cannot produce. What happens when basically just about 60% of all forms of expression around are generated by technology, be hardware or software, which is produced in a center of humanity, which happens to be right here. I think there's a lot of reason and justification to be concerned about what happens when we start bringing computers down to schools in the middle of Nicaragua, the middle of Africa or Asia, and teach them to use Photoshop and stuff like that. Now, there is actually a lot of experience in terms of previous technologies that through thousands of years of evolution managed to maintain enough specificity, both material specificity in the evolution of the technology and expressive specificity in what's done with the technology, that this problem didn't seem to be quite that important. For example, talk about weaving. Simple idea. Requires technology. You go across the world, just about every advanced culture, and even every basic culture, has applied some level of weaving thinking and weaving technology to expressing themselves, to clothing themselves, to communicating with others. And the technology tends to change a lot, even though the basic premise is the same. And from those material changes, what you get is incredible variety and consistency and continuity of cultural identity as expressing both, and this is what's most important, in the machine and then in the expression. You see, a lot of people tend to think that all you need to do is give computers to people and they will express themselves. Not quite the case in general, because what you need is, is the very material specificity of the technology that somehow needs to reflect the natural processes of a culture. It is, what you can do culturally with any specific machine is definitely embedded in the specificity of the machine itself. Another good example is filmmaking. People tend to forget about this. When Edison came up with his original camera here, at the same time the Lumières did something similar in France. And yet, because of probably some cultural assumptions on the part of the inventors, but also some material limitations, their inventions were radically different. While the Edison's camera was a very big camera that basically required the building of this building called the Black Maria at the time, which was basically the first studio ever built. So he had no choice by the set of choices he had made in the invention of the technology, but to have a static camera, bring actors, and shoot them in front of a camera. There you have the birth of the studio system. On the other hand, the Lumières had a completely different approach. What they wanted to do was going around the world, and so here you have their experience. And so they came up with a small camera that was camera and developer and projector at the same time. And so they went around the world, you see in the slide right, in the little image right here, taking images. I think it's not difficult for film theorists and film historians to trace from those inventions two very different schools of expression, two very different forms of culture expressing themselves through technology. Okay? Now, we come to the point of, so what do we do with computers? I mean, there isn't anybody in Bolivia about to start to invent a different type of computer, and there isn't anybody in Africa about to do the same. And yet, of course, the computers are going to get there. There's a lot of work being done in terms of alternative forms of computing. I mean, one of the key aspects of the computing that we tend to talk about is this thing about personal computing, right? This vision that emerged probably in the early 60s, and it continues through today. And a lot of people are trying to find alternative visions or alternative models for that. You guys at Google Up, for example, have been doing a lot of work in terms of social computing. Social computing offers some very interesting possibilities. You know, the creation of shared content, user-centered ontologies, semantic communities, and yet somehow, you know, is still within the context of the word, within the context of just language. The possibilities that social computing opens for users. On the other hand, you have community computing. The idea is different. The idea is to put a bunch of computers in a community center somewhere and train people to be able to use them. Again, user-centered design, user empowerment tends to be, you know, there's some great projects in Philadelphia, in Chicago, all around. In India, they're doing a lot of work like this. There tends to be they go a little farther. They start tweaking with the machines because together they're there. So there's a lot of either retro-engineering or repurposing of technology. And yet I still think it doesn't go quite deep enough as to promote the evolution of cultural identity in the context of computing. Then you have ideas emerging of India, especially in Pakistan right now, on folk computing. The idea is that what you do is you try to create interfaces that somehow are reflective of the modes in which people express themselves, move around the city. So body language and language in general become a lot more important. Again, a lot of cultural reflexivity in the content. Still, you know, my feeling is, or our starting point for the project that I'm just about to tell you about, is that if you really want to have a community, engage a community that is not your white middle class, Northern California, or even Los Angeles community. Truly engage computing at the level of empowerment, community development, and their possibility to be in control and change of their own world. Where you need to go is what I would call participative design. There's a lot of traditions of systems, collective design, especially coming out of Scandinavia, Norway, and places like that. And, okay, those are not there. Sorry about that. And so we have there's a set of opportunities emerging right now as computers move into urban space. Okay, definitely this is happening. I think there's a tremendous need both in academic environments, community environments, and social environments to start thinking about what is the alternative to the current model of engineer-centered design as to get the communities more involved. Again, our idea is that if you're going to set up computing centers in urban space, in communities, you have to involve the community in the design process. It's not just about bringing the technology in. We have a great opportunity right now. I need 5 more minutes. Los Angeles is going through an incredible process of change. There is a lot of dialogue about the sort of what they call the greening of the river or the revitalization of the Los Angeles River. And there's a great opportunity to talk about the relationship between urban systems, computing systems, culture, and community. A dialogue in terms of how do we want computers to actually work in real space, in terms of some of the things Jeff was talking about, tangible. One of the problems Los Angeles has had traditionally is a lack of physicality in a way, sort of a difficulty in terms of growing roots into physical space, a difficulty in terms of even knowing there's a history to Los Angeles. So let me close this. Just a second. Actually, let me just jump ahead. I know you gotta get out of here. All right, there we are. So one of the key things happening in terms of the changes in Los Angeles is the creation of the new Los Angeles State Historic Park. It's a space of 32 acres, 5 blocks from downtown Los Angeles. That was the first train station of Los Angeles, the first Southern Pacific station of Los Angeles. That's a place where Portola camped when he was with his mission coming up in terms of finding places for the missions. Through this field is where the Zanja Madre, which was the original water system for Los Angeles, was built. Very important, probably the most important historical asset of Southern California. We have entered into an agreement with state parks in terms of using this particular space because of its history and how much the community is involved in designing it, in terms of creating what we call a cultural civic computing system for it. It's actually probably going to be, these are some historical images of things that went on exactly on that field. Again, if you look just carefully, this is the Los Angeles River in about 1874. And this right here is this field where downtown is right here. And this is this gigantic field that basically where Remap and engineers are going to be able to work together in terms of creating a wireless city-broad computing system. It's fantastic space. It's really incredible. And I wanted to show you just one more image out of here so you get a sense of the potential of the space. I don't think there is any sort of wireless urban computing opportunity such as this in the country right now. There you go. There you see the field with downtown in the back. There you go. This is, in the middle, you see the green field. Again, it's 32 acres. Chinatown right on one side, Lincoln Heights on the other, Solano Canyon on the other. All of these communities. So the idea is, again, to engage these communities in a long-term process of dialogue about the role of computing in terms of the development of their own identity, developing tools for community empowerment, and get them in the driving seat in terms of how technologies are applied. That's about it.
So now you've heard just about everything from UCLA, and we wanted to leave you with a few minutes for questions. And we finished actually in an hour, I think. So if there are any questions left for the folks that are here, we'd love to answer them. Yeah.
Is there a city or a state or a place somewhere in the world that's kind of like a leader in wireless sensing, stuff like that? Kind of like South Korea's for mobile phones and stuff.
That's a good question for Deborah. I'm not sure if I know the answer. I know there are some campuses.
Country. But that's more on, not so much on the, it's not in urban sensing, but the country Australia. From precision agriculture to ecological, lots of remote sensing, the place is so big. I think as a country, it's Australia. For urban sensing, I'm not sure. Clearly, there's lots of, I mean, the use of cell phones in all kinds of social networking ways in Japan is always referred to. But in terms of embedded sensing, live your country, but not a city.
I know that New Jersey Institute of Technology is doing stuff on campus that is getting in that, but as far as like an entire city that has that sort of thing, I don't know. It tends to be more smaller locations, or in this case, scientific applications that are smaller in scale than the city at this point. Sorry. Okay. Other questions or any? Okay. Okay, so thank you very much. And I think everybody's going to be here. If there are one-on-one questions, we would love to hear it.